talking about the two topics. One is the hybrid search, and another is the task type embeddings. And if we have time, I'd like to share interesting demos at the last. So let me introduce myself quickly. So am I sharing? Not yet. Oh yeah, I'm sharing.
You're sharing. I can see it.
Okay, thank you. Yeah. So I'm Kaz. I'm a developer advocate for the Cloud AI team. So Cloud AI team is the entire the big teams with the SWEs and the product managers who are building the Vertex AI products, including the Gemini API and others. And I'm a developer advocate, which is responsible for writing blog posts or writing building demos or sample notebooks or creating slides and so on. And right now I am supporting the product called Vertex AI Vector Search and the embeddings API. So which will be the main topic for this session. Okay, let's get started. So I start talking about hybrid search first. Use vector search. So the two topics we'll be covered today is all about how to build your RAG, and especially how to improve the search quality of your RAG systems. I suppose many of you have heard about what is RAG, Retrieval Augmented Generation. Let's do some have some recap on the technology. So in the early days of the GenAI, like a couple of years ago, there's only a model where you can ask many questions, like any contents on the movie Titanic and its music. You can ask the OpenAI or Gemini models, and the LLM can get back with answer with its own knowledge. But that is the reason why the enterprises cannot bring the technology into the production, because the LLM, as you know, hallucinates. Yeah, make a mistake. So that's the reason why people are excited with the technology called RAG, Retrieval Augmented Generation. It sounds like very technical or scientific, but actually it's a very simple idea. So instead of having LLM directly answer to the questions, let the LLM make a query on the retrieval engine, search engine at the back end, and retrieve some relevant documents and embed the result into the prompt, so that the prompt will be like this. So the user asked about the movie Titanic and its music, and here's the what you get with the retrieval engine, like a search engine or databases. Here's the database search result, and please summarize the answer you should answer to the user. So that by using this kind of technique, and embedding the retrieval result in the prompt for the LLM, so that you can reduce the risk of the hallucinations quite much less. It's not possible to 100% hallucination free, but still you can reduce the hallucination risk so much. Okay. And in many cases, people likes to use the vector search for the semantic search for the retrieval, the relevant documents or relevant the items. But actually, you don't have to. There's no rules that you always have to use the vector search for building a RAG. It's just that one of the latest technology for the search. But actually, based on your business requirement, you can choose any arbitrary search engine. For example, you can use the MySQL that can run some SQL query to retrieve the documents based on the user query. That is totally okay. And also, or maybe, for example, in the past, I built on some demo that uses the Wikipedia pages for the RAG. In that case, I use the Wikipedia API to make a query to the API to retrieve the page for the topics, the user query. And with the page content, Wikipedia page content, I have let the Gemini answer the questions. That is totally okay too. So there's no strict rule that you always have to use the vector search at all. The reason why people are using the vector search is that because it provides the semantic search capability. Semantic search, as its name says, it searches the items or documents by its meaning rather than the keywords. So you can also use the Elasticsearch or the other open searches or the keyword search as well. But using the semantic search, you can get the relevant documents because it looks for the similar meanings to the queries. Yeah, let's do some recap on the semantic search. So, semantic search is based on the vector search and embedding model. Embedding model is the natural language model that generates the vector called embeddings. So embeddings is just like the bunch of the numbers that represents the meaning of any arbitrary content. For example, if there's any documents that talks about movies for 10% and talks about music for 2% and talks about the actors for 30%, maybe the embedding model could generate three-dimensional embeddings with the 0.1, 0.02, or 0.3. This is a very super simplified example. So in real world, the embedding models we are using at Google usually generates the embeddings with the 768 dimensions or 1400 dimensions. And it can represent any kind of the categories or the meanings or nuances or by using those the hundreds of the dimensions. But this is a very simplified example. For example, if there's a very simple model, embedding model, then that model would generate this kind of the embeddings with three numbers. So embeddings is just a bunch of numbers that represents the meaning of the content. And the entire embedding model generates the embedding space, which is like a map of the meaning of the all documents you use for training the embedding model. So by using that embedding model and embedding space, it's super easy to find similar documents or any other items by looking at the neighborhood or the cross areas to the target query document or text. So that's how the semantic search works. And by using the vector search, you can run the vector search, semantic search at very quickly, at very short latency. For example, the vector search means that you have to find the other vectors that has the closer distance between the two vectors. That means if you have for example, 1 million documents in your vector database, you have to, with the naive brute force ways, you have to going through all the 1 million vectors, calculate the distance between the query vectors and the document vectors for all the 1 million vectors. That takes tens of seconds if you do that with the naive way, the brute force way. So that's the reason why people are using so-called ANN, approximate nearest neighbor technology, that can find the nearest neighbor, the closest the embeddings in the milliseconds. In case of the vertex AI vector search, it can find the nearest neighbor, the closest vectors or embeddings within like 10 milliseconds or 20 milliseconds. Even when you put for example, the tens of billions or tens of millions or even billions of the entities can be held in a single index, still you are seeing milliseconds latency rather than spending tens of seconds for going through all the calculating the distance with all the vectors. So that's why people are using vector search for semantic search. So that was the quick recap of the semantic search, and that is the technologies many people are using for the retrieval part of the RAG system. But that is not a silver bullet, because the semantic search has some very have the weak point. For example, what if the user asked the LLM about, please find the product with the item number 1234767, or can you find the item names ASD, So they don't make sense at all. But if you go to the usual e-commerce website like Amazon.com, you would usually want to use the both natural language query and or you can you'll be trying to find a product by using the exact keyword or the product numbers. But still, you can expect the keywords or product numbers could be used for the finding the target items, just like the keyword search engines like the Elasticsearch or OpenSearch. That's how it works. But actually, the semantic search cannot do that kind of the keyword search or exact match kind of the token-based the search. Because as I mentioned, to do the search, the semantic search uses the embedding model. So embedding model, things that embedding model doesn't know could not be found with the vector search for the semantic search. That's the weak point. So that's the reason why in many cases the RAG developers are seeing the very poor search quality when they are trying to bring the RAG system into production. So that's the reason why, in many cases, especially for the productions, you'll be end up with the building a hybrid search systems. That is a combination of the keyword search or the semantic search. By the way, the hybrid means the hybrid of the any arbitrary technologies, so that it could be sometimes the graph databases or it could be sometimes SQL databases. But in this case, I'll talk about the combination of these keyword search and semantic search. So by using the hybrid search, you can take the query like a product number query or the partial keyword match query or the semantic query within natural language. Any queries can be handled by the hybrid search system. And at the back end, you'll be running the two different queries against those the keyword search index and the semantic search index, and get the merged the two results into the single result. Actually, many of you have been using the hybrid search technologies for many, many years already, because Google Search is one of the most popular hybrid search systems since 2015. So Google Search started as the keyword-based search over 20 years ago. But at 2015, Google Search introduced the first semantic search with the vector search backend inside it. So since then, the result you are seeing with Google Search is the result merged from the two search results, from the one keyword search result and semantic search result, and re-ranked based on its own re-ranking the model. By the way, if you have any questions, please feel free to add those questions to the chat box. So I will try to pick up any questions to answer them. Okay. But if you want to build your own hybrid search systems by yourself from scratch, it's not easy to do. This is a simplified diagram how the Google search works at the backend. It takes a query and then it pre-processes the query with this many kind of the relighting, including the knowledge graph. The Google search uses the knowledge graph for the query rewriting. And then it runs the query on the two different backend. One is the keyword search, maybe the one of the largest keyword search backend, the largest and fastest. And there's another backend, maybe the one of the fastest and largest, the vector search backend in the world. And those two the search indexes are serving to the billions of the users every day. And then it merges the result from the two different index and apply the ranking, the algorithms called rank brain. So if you're interested in the ranking algorithm or the Google search, please Google with the keyword rank brain. That is the name of the model they're using for re-ranking and the filtering. But maybe the Google search is one of the most precious and maybe expensive asset we have built at Google for the last 20 years. So it's not easy to reproduce the same things in your enterprise systems. So instead of that, so we provide an easier solutions called hybrid search functionality in the Vertex AI Vector Search. Vertex AI Vector Search, I don't talk much about the product itself today, but let me quickly introduce the product. Vertex AI Vector Search is the product from the Google Cloud in the Vertex AI platform. That is a product. Actually, all you have to do to use the product is just hit the API, like importing the data into the vector search index, or maybe calling the API to the running a query visit. But under the hood, what vector search uses the scan technology, the vector search technology shared with Google Search, and many of our major services like YouTube recommendation or Google Maps recommendation or the Google Play mobile app recommendations. Almost all the Google services are sharing the same vector search technology that is called SCAN, SCANN. And Vertex AI Vector Search is a productionization of the scan technologies as a managed service. So you don't have to do everything from scratch. Instead of having you installing the scan library on the GKE or the CloudRun instance or manage it by yourself, all you have to do is just create an index and deploy the index to the endpoint so that you can start calling the index for a query. So it's super easy to get started. And now the Vertex AI Vector Search supports the hybrid search functionality. So what is hybrid search? Let me quickly introduce the technology, basics of the technology. The keyword search. So what we want to do is to combine the keyword search and semantic search, because as I mentioned, semantic search still has many weak points. So we want to run the keyword search. Keyword search is sometimes called as token-based search because in many cases, the keywords are split into the single word or subwords called tokens. So all you have to do at first is to use open source tokenizers from, for example, tokenizers in the scikit-learn to split the single sentence or the entire document or paragraph into the tokens. That could be words or subwords. Then by looking at the tokens, you can use the vectorizers called the TF-IDA for BM25. Usually they are available as the open source to generate the embeddings called sparse embeddings. Sparse embeddings is an embeddings that represents the frequency of the usage of each tokens or words. So for example, this is another super simplified example. If a single sentence uses the word movie and music, then the specific dimension in a very sparse embeddings. Sparse embeddings could have the hundreds of the thousands of the dimensions. So it's called the sparse. And there should be some dimensions that represents the word movie. Another dimensions represents the music. And you can put the 1.0, 1.0 on these dimensions. So this entire sparse embedding represents the distribution of the word usage of this sentence. Okay. So as I mentioned, there could be a possible tens of thousands of different words in an entire document or set of documents, corpus, so that there will be an dispersed embeddings could have the tens of these thousands or millions of the dimensions. It's so sparse. But most of each dimensions would be a zero, non-zero value. And also, only a few dimensions could have the non-zero values in it. So that is the reason why they call it as a sparse embeddings instead of the dense embeddings. Usually, the embeddings used for the semantic search is called dense embeddings. That is generated from the language model or the deep learning, deep learning based the embedding models that would have like 700 dimensions or 1400 dimensions. All the dimensions would have the non-zero values. That's the dense embeddings. But sparse embeddings representing the distribution of the keyword usage would have the only a few non-zero values. That is reason why they call it as a sparse embedding. And the sparse embedding space, if you take a look at the entire space, then it works as a map of the keyword distribution of each document. For example, if a single sentence or document uses the two words movie or music, then it would have a 1, 1, 0 in the three-dimensional the embeddings. So that you can use the ANN technology, the approximate nearest neighbor, the vector search technology, to find the closest, this similar document, similar in terms of the document keyword distribution in the document. So those sparse embeddings doesn't take the meaning of the content account. So it doesn't care about the meaning of the keywords or sentence. Rather than that, it just cares about the distribution of the words. So that's the basics of the token-based search or keyword search. So for example, if the user asked for finding items with the keys as the exact match or partial match, then you can use the token-based the sparse embeddings on the vector search to do the keyword search. Another way is to just have two different search engines. You can just continue using the traditional keyword search engine like Elasticsearch or OpenSearch, and use the another vector search engine for the semantic search and merge the two results into one. That is possible, but here's another easier way. So you could have the single index that would have the both sparse embeddings and dense embeddings for the hybrid search. So I'd like to show what kind of the code you have to write to implement your own hybrid search. So to use the token-based search, yeah, maybe I can actually show the notebooks. Everything I'm explaining here is available on the GitHub repository. Yeah, maybe I can share the link here on the chat, so you can try it out by yourself. So this is the notebooks, and the first half is the same content as I explained. And you can install the SDK and set up the environment variables for the Google Cloud project. Then you can get started with the trying out the sparse embedding and the token-based search. So for the vertex area vector search, to use the token-based search, you will be preparing for the dataset with this format. In the JSON, you could have the ID of the entry, each item, with the property called sparse embedding. And each sparse embedding will have the values like this. As I mentioned, there's only a few the non-zero values in a large dimensions, large embedding space. So the sparse embedding will look like this. So it's few values and the location of each dimension. And in these samples, we are using the 200 rows of the Google branded goods name, like a Google sticker, Google Cloud sticker, or sweater. And it uses the TF-IDF vectorizer to generate these sparse embeddings. So the vertex AI vector search product itself supports the hybrid search, but it doesn't provide any the required functionalities for using that, like the tokenization or vectorization, because in many cases you can use the open source the libraries, like the TF-IDF is available in the scikit-learn. So it's the one of the most simple way to generate your sparse embeddings. So if you want to use the TF-IDF, which is the most classic the vectorizer, then you can just import the scikit-learn, create the TF-IDF vectorizer, pass the entire corpus to build a model for the vectorization. So you can use the vectorizers to pass the text to get the sparse embeddings like this. For example, the text from dinner pin would get the sparse embedding like this. There'll be three values in these sparse embeddings, the position of each dimensions. So this is the sparse embeddings. And you can get the same kind of the sparse embeddings for all the 200 items and store it in a JSON file. And then it's ready to build your sparse embeddings index on the vector search. This is the function to build your vector index with the product. So you specify the bucket, Google Cloud storage bucket name URI, where you store all those JSON file. and you can specify the dimensions, and you can specify how many the items you want to retrieve usually. Then you will have the embeddings created, and you always and also you want to use you want to make the create the endpoint that works as the server API server for you that runs your index on it. So you will create the endpoint, then deploy the index to the endpoint. So it's ready to take the query for your sparse embeddings. To make a query on the sparse embeddings index, you can create a hybrid query object like this. So for example, if the user query is kids, then you can create the hybrid query object and put the sparse embeddings for that query into the sparse embeddings dimensions and values. That's it. And finally, you can make a query, find names. This is the function to make a query on the index with these sparse embeddings. So you'll get the result like this. So you notice that the result will have the kids inside it because this is a token-based search, keyword search, not the semantic search. So that was the how to use the token-based search. By the way, there's the other options for the vectorization to create these sparse embeddings. TF-IDF is the one of the most classic one, and many people are using BM25. This is the improved version of the TF-IDF, another classic, the algorithms. And recently, the new popular vectorizer called Spread is getting popularity, but it's as some it's not so lightweighted, so maybe it can you can see the little bit the better improved performance on the search quality, but instead you'll be seeing some it's not so lightweighted library. You have to import the PyTorch and train your model for the spread. So there's a pros and cons trade-offs between those, the choice of the vectorizers. So that was how you can use the token-based search. So now let's take a look at how to use the hybrid search. So to do the hybrid search, you have to prepare for the both sparse embeddings and dense embeddings. Dense embeddings, you can keep using the existing embeddings from the Vertex AI embeddings API, or if you're using the OpenAI embeddings or any other embeddings from the open source or the other vendors, you can keep using that. Yeah, but actually, using the Vertex AI embeddings API is one of the easiest way. You can just, write a few lines of code like this one to get the very high quality dense embeddings for the semantic search. So let's take a look at the actual code. Yeah, I just create a model for the embedding and get the embeddings for the text. Try to with the Chrome Dynopin. And to make to build an index for the hybrid search, you'll be generating both dense embedding and the sparse embeddings for the same the item text, and pass it to the JSON file. Yeah, this is the JSON file format you'll be storing on the Google Cloud Storage for single items. Since we have the 200 items here, so there'll be 200 lines of the JSON entry in a single file. Then pass the JSON file to build an index on the vector search. This is the same the functions as we have used already. And then make the hybrid query by using the same hybrid query object by passing the dense embeddings for this text query and sparse embeddings for this query, and pass it to the query object and run the query. So the end result is like this. So you'll be seeing the most relevant result at the top, because as you can see, the result has the higher score on both the semantic search result and the token search result, like this. So for the semantic search result, this Google Blue Kit sunglasses has the highest score, and also in terms of the keyword matchings, it also has the highest scores. For the other items like Google Y Classic UST, because it doesn't match with the keyword keys, so it doesn't have any the high score with the sparse embeddings. The score will be 0. But still, the word like UST has the very high similarity with the word keys, so that it will have the some scores, high score on the dense embeddings, this semantic search. So for those items should be ranked as in the middle of the entire the ranked set, the result you'll be seeing. This kind of the ranking is done by the algorithm called the reciprocal rank fusion, or RRF. That is the algorithms for merging the two different the search result into the single search results. And if you really want to the hybrid search into productions, in many cases you may want to think about to have the re-ranking the component after the retrieval. This is the so-called two-phased the retrieval and ranking systems for the many information retrieval systems in productions, so that you can get a much higher search quality or search relevance by using the re-ranking algorithms. In this session, I'll be not talking about the re-ranking in depth, but you can check out our ranking API on the Vertex AI to learn more about the re-ranking. So that was the quick introduction of the hybrid search. As I mentioned, you'll be getting the merged result from the both semantic search and keyword search. So that can reduce the risk of the seeing poor search quality on your RAG systems. Okay, I got a questions on the chat window, so let me take a look at it. Boolean operations on keywords can be done in parallel, not using the vectors embeddings only. Boolean operations on keywords, that's a great question. Actually, the current vector search product doesn't support the vector operations on the keywords. So, for example, if you want to specify the conditions, like the query answer should always have to have the both keys and t-shirts, then maybe you may want to combine with the filtering functionality. The vector search product has the filtering functionality. So if you can add the labels, there's the filtering functions allows you to put the label on each entry. So for example, if you put the categories like a t-shirt category or kit category to each entry, then you can use the filtering function of the vector search to output the result that has both the t-shirts and kits. Maybe that could be the answer. Another question, for sparse embedding, a long paragraph, a lot of vocabulary, will it exceed the defined dimensions? No, usually the vectorizers like a TF-IDF for BM25, create an sparse embeddings within like tens of thousands of dimensions. So yeah, usually you don't have any issues with that. And also, the vector search sparse embeddings, the hybrid search functionality doesn't have any upper limit, because as you saw, the format we are using for representing the sparse embeddings doesn't have any specific upper limit for the dimensionality on the sparse embeddings. It just says the position of the embeddings, like 200 or the 1000 or the 60,000. So you can put any arbitrary dimensionality in the sparse embeddings representation. Can you share this slide? So ADAS when actually we are not sharing this particular slide, but you can have the same content on the notebooks. So it'd be great if you can use that. And also, there's a video recently published with the same content as this slide. So please go to the YouTube and search with the hybrid search video is not published yet. That's going to be published today. It will be published in 9 p.m. today at Pacific time. So after that, please search with the Vertex AI hybrid search or something on the YouTube. So you'll be seeing the video. Here you have the same content as this slide. Another question. Not sure it's being mentioned, but there are any benchmarks comparing the hybrid method and non-hybrid one. For this particular project, we haven't done any benchmarking yet. But yeah, usually the hybrid search is required by the customers as a functionality. So for example, the end customers ask you to have the RAG systems searchable with the product numbers or the newly added product names added yesterday, then you always have to use the hybrid search. So it's not about the search quality, more about the functionality the customer requests. Because the semantic search cannot handle those requests like product numbers or the newly added the product names. Okay, so we already have used the 45 minutes. So let me quickly go through the second topic, which is the task type embeddings. This is again about the search quality issue of the RAG systems. So many cases, because the people are still using the usual similarity search with the RAG systems and semantic search, it actually leads to the poor search quality. Why is that? So I'll skip the basics of the RAG part. Because in many cases, RAG system is used for the question and answering kind of use cases. But think of the actual, the question and answers, like why is the sky blue, and the answer scattering of the air can be seen as blue. Each sentence has quite different meanings. They are actually not semantically similar, but still 95% or more RAG systems are trying to use the similarity search to find the relevant document while they are not similar. So this is the problem. And also there could be another use cases like recommendation systems, like you would ask to LLM any present for my son, then the answer could be a Nintendo Switch or Lego set. Those sentences are not similar to the question itself, right? So that is the major reason why people are seeing the poor search quality on the RAG systems. And this is actually not a new problem. This is a classic problem for the information retrieval systems in past 10 to 20 years already. And for example, Google search, if you make the enigmatic query or like this one, the insights how to manage a green. Actually, this query doesn't make sense to me, but Google search can make sense on it because it understands the relationship between this specific query and the context where people are talking about those topics. Actually, this is about how to manage the members in the teams by putting the colors on each personalities. I don't know much about that. But the Google search is all about training a machine learning model, deep learning model that understands the relationship between the query and the relevant documents. And the similarity search doesn't solve this problem. So if you're a professional of the information retrieval or data scientist, you may find that this is the popular solutions for this problem. Zero encoder or the tutor model is the most popular solutions. Actually, the neural matching in the Google search is the one of those zero encoder model that has the two part in a single model, running the embedding space for the query, running the embedding space for the documents, and learn the relationship between the two models, two embedding spaces. That is how the Google and other information retrieval professionals have been solving this problem in the past. And also the way to solve this problem is using one of those advanced RAG options, advanced RAG ideas, like the HYDE, HYDE, or query expansion using LLMs. because LLM is smart enough to make this kind of filling the gap, the predictions, right? For example, why is the sky blue? LLM itself can predict, oh, maybe answer could be the scattering, so that you can search for the any documents that has the scattering in the documents. That is how the query expansion or the hide try to fill the gap between the query and documents. But the downside is that you always have to wait for a few seconds for each query, or spend 10 times higher cost for using the LLM to solve this problem. So you can solve this problem, but it's not fast and inexpensive. So to solve those problems, we provide a new type of the task type embeddings model that is developed by the Google DeepMind and research team. Oh, I got questions. If the person meetings has generated from the corpus of the documents, do you run into issues or what a token where is 90% the corpus documents? Oh, do you run into this? Yeah, so usually the corpus is trained each time you imported the entire set of documents. For example, if you have like tens of thousands of the product, then you will be training on the corpus at that time, so that there will be all the tokens used for all the product names. Okay, so going back to so task type embeddings model provides the new type of the embedding space that has that captures the question and the answer relationship between those two embeddings. The question and answers could be close enough to be captured by the vector search. And behind the scenes, the research team used a very novel way to do this. The basic idea is to train a dual encoder like the traditional the Google search model. But they have used the LLM to generate the huge the training data set for training the dual encoder with the query and relevant documents. And they also use the LLM to put the label, like these pairs of the query and document is the positive pair, or this query and document pair is a kind of the negative pair, so that they were able to train a much smaller dual encoder model as a distribution of the original LLM. So you don't have to use the original LLM. Like you don't have to wait for a few seconds, spend like a 10 times higher cost. You can keep using the same 1/10 cost compared to the LLM with this small embedding model and maybe the milliseconds latency. But it inherits the intelligence, the reasoning capability from the original LLM. And to use the task types, there are some specific parameters, like you can specify what kind of task you are using this embeddings for. Like, are we retrieving retrieving the documents with a query? Are we trying to find the answers to a specific questions? Are we trying to find a document that could be used as the fact for the fact verification? Or are we retrieving the code snippet for the questions from the developers and so on? So you can specify the task type based on your the use cases. The result is like this. At the left side, you are seeing the result from the usual semantic search similarity. And the question is, what is the best birthday present for my son? As long as you are using the semantic search similarities with the OpenAI embeddings or the embeddings API, the answer, my son says Taylor Swift's birthday is December 13th, gets higher similarity with the questions. Although this sentence doesn't answer to the questions at all, it's not relevant, but higher similarity. So that's the major reason why the many RAG systems are seeing a poor search quality. Whereas if you specify the question and answering as task steps, the statement Lego set would get the higher similarity to the original question. So I have done the benchmarking with the 10,000 different question and answers pairs from the open source dataset. And the result is like this. So you'll be seeing like a 40% increase on the search quality, MRR, for the 10,000 question and answer pairs compared to the usual semantic similarity. So in the end, you'll be seeing the much better user experience by building the RAG systems by using these task type embeddings in your systems. So yeah, actually there's notebooks to trying out these task type embeddings by yourselves. So I put the link to here. So please try out. So that was the topics. Is there any other questions you have?
Feel free to send any question to the chat. If you prefer to speak to ask questions, you can raise your hand. I can unmute you. You can speak to ask questions to the open discussions.
Isn't the URL encoding highly subject to change over time? Yeah, so yes, because it's a model that learns the relationship between the question and answer or query and documents. So it's totally depending on what the domain or problem set you have. But for example, if it's on just on consumer products, then usually the majority of the relationship doesn't change. So you can use the task type embeddings for solve the problem. But if your the business problem is something like very specific to some industry that where the relationship changes all the times, maybe you have to design and train your own neural encoder model and run as MLOps pipeline to continuously training the neural encoder model, for example, every week or every day. And here's the QR code to answer to this survey, quick survey. So please take your times for answering to the 1 minute survey for this session. Have you seen any customer using embeddings for the video searching at the frame level? Is latency low for such systems to be operational? Actually, with the Vertex AI embeddings API, we support the video. And inside the API, it takes the still images from each frames, like still images from the every 15 seconds to use the image embeddings for the video search. And yeah, it's a batch processing so that the latency is not as fast as the usual the embeddings generation for these still images. So usually, yeah, for the video use cases, the generating embeddings is usually processed as the batch processing. Yeah. How does this compare to using graph search to component the graph search to complement this semantic search? Yeah, this is a great question. So, for example, Google Search uses everything. So, Google Search uses this kind of the URL encoder to capture the relationship between the query and answers documents. And also, Google Search uses the knowledge graph for the query expansion and document expansion as well. So Google Search uses every possible ways to increase the search quality. By using the knowledge graph, you can expand a single query. For example, when you ask about Elon Musk, then the expanded query would automatically add another very related the keywords like the Donald Trump because they are close right now. So that is how you can improve the search quality by using the knowledge graph. Any other questions?
By the way, I also enable you can unmute yourself if you want to speak, to ask questions or discussions. Feel free, you can just unmute yourselves to speak, to ask questions. And also please to scan the QR code to fill out the survey to let us know how the sessions goes and also other sessions or content you want to learn to helping us to prepare for the next events, next topics.
I got one question. Can this be used for whole PDF retrieval? For low cases, low. Okay. So yeah, this technology doesn't include how to process your PDF file. So if you have your documentation as a PDF, maybe you can take a look at our other solutions like there's a product called Documentations AI that has the whole toolset for importing any the formats like a PDF or the image files for the search engines. Another product is the Vertex AI search. So today I have talked about the Vertex AI vector search that supports only the vector search part. But there's another product called the Vertex AI search that is a kind of the end-to-end solutions for the any search requirements. So you can take a look at the product, and so with that product, you can just upload your PDF on the Google Cloud Storage so that it can be automatically processed to be indexed to the search engine. Well, can we have the recorded video or for this session? Yeah, this is the questions to the organizer.
Could I ask a
Do you have
question?
any? So go ahead.
Please go ahead.
Yes, thank you. I was wondering, let's say that you have a very large context window available. So you've got a lot of space in the context window to work with. And you're working with a very domain-specific task. What are the trade-offs between putting information in the context window? Perhaps, that would give you a more complete representation than if you put something in the RAG. What are the trade-offs between the two?
Yeah. This topic has been discussed in many the blog posts and articles, long context versus RAG. So I have the same opinion with those the blog posts. So long context takes much longer times and takes much longer cost. Also, we provide the context caching technologies, but still, if the document is quite large, then the cost and latency is much larger than using RAG. But at the same time, as you mentioned, the RAG lacks all the context between each document. RAG is kind of the mixture of the traditional information retrieval technology and the LLM. So it has its own limitation, but still, because it's just a search systems, it doesn't cost much. The latency is like a millisecond latency. You can handle like a millions or billions of documents. So that's a pure trade-off. And if you have enough budget and times, I always recommend the customers to try out the both the ways. And in the longer term, like a 5 years from now, or maybe more, I personally expect that the long context would have much less latency and cost, and that could be possibly, replace the RAG in long term. But right now, it's not enough.
Okay, thank you.
Thank you. Do you have any tip to how to test hybrid search? Yeah, so for testing the search systems or RAG systems, it's totally it should be designed from scratch based on the customer's requirements or user's requirements. So there's no standard benchmarking for the RAG or the search engines. Or you always have to set up the measurements like testing data sets and what would be the best metrics to capture the user experience, not just the latency or the cost. So yeah, it's totally depending on the user requirements, use cases. Okay, I think that's it. Back to the organizer.
All right. Thank you so much, Kaz, for the great presentation and Q&A with our attendees. Thank you, everyone, for joining us today. Let me know if you have any last-minute questions. Again, meanwhile, feel free to, if you have not done yet, feel free to scan the QR code to fill out the survey. It's really helping us to improve for the future events. If no further questions, we can conclude today's events. Again, thank you everyone for joining us today. I think the slides, you cannot share the slides, but oh, by the way, for the recordings, is it okay to share with the attendees for recordings?
Yeah.
Okay, great. Yeah.